We will start today from where we stopped yesterday. Just brush up where we stopped, and from there we will move to some new topics. Okay? So I have come with the ball which I took yesterday home. So I brought back this ball, blue ball. Okay, if you can see this. So we took this ball. So what did we establish yesterday? So assume there is one ball with mass m. Okay, and let us assume it is having some speed. We're starting. Now somebody is hitting the ball. Golf. Who plays golf here? Anyone? Anyone plays golf? No. Okay. Any cricketers? Avinash, does there accept? Avinash, accept and Avinash? Rishikesh also. What do our girls play? What do Mega, Sivananda, Ananya, don't play? Ayati, what sports you are engaged into? Elisa?
Tennis.
Tennis, wow. Okay, then?
Sir, basketball and badminton.
Wow, wow, wow. Okay. So this, we will now take the example of tennis, okay, and basketball or something, right? Okay, so badminton everyone understands. So the same thing applies for tennis or badminton also. Assume this is a shuttle or a ball, badminton or shuttle, you hit, right? What will happen if you hit in this direction? What will happen? What happens? Tennis ball you hit.
It travels with speed.
Acceleration happens and the ball moves forward.
Yeah, ball moves forward in the direction of the force, right? Direction of the force, and it has some acceleration. What if you hit like this? What if you hit like this?
The ball moves backwards.
We don't know.
Yeah.
Yeah, but it will decelerate. Speed will reduce, right? If you are able to overcome its momentum, then ball will move backwards. Otherwise, you can't be sure about it, right? So if a huge truck comes at 100 km/h and Alan stands in front of it and apply a force back, will it go back?
I will be crushed to death.
Yeah, right. So for that you need to have Superman and things like that. Otherwise you won't be, right? So you don't know whether it will go back, but you know it will decelerate, right? So if it is in this direction, it will accelerate. So assume it accelerates. Okay, it moves. Assume its final speed is v. So what is its acceleration? How much is its acceleration?
V
Then is
minus U by T.
v minus u by t. What is this? Change in speed in 1 second. That is acceleration. So many people have much doubt what is the difference between speed and acceleration. So this acceleration business is what is one of the major contribution of Sir Isaac Newton. Speed concept was there much before. Now acceleration is change in speed. It can be increase or decrease. Okay, change in speed in 1 second. That is what we normally call as rate. Rate of change of speed. Rate of change of speed. What does it mean? Change of speed in 1 second. That is what we normally call as rate. What is meant by run rate in cricket?
Each over how much
Yeah,
runs.
the number of runs per over. So there the unit is over. Is it not? There the unit is over. Here the unit is second. Change in speed per second. So rate is normally used to tell what is that quantity happening in a unit period. It can be a time or over or things like that. Yeah, Understand? Okay. So now Shivananda told acceleration is the final speed minus initial speed by time. So final speed minus initial speed means v minus u is the change in speed per time. Is there any other method to calculate acceleration? Any other way?
A is equal to m by f
Yeah,
by f.
yeah, correct. So even if you don't know the final speed, if you just know what is the force applied and what is the mass of the object, you can get the acceleration. That is actually Newton's second law. F is equal to m into A, or A is equal to F by m. So think about it. What is the meaning? So every equation, if you really understand, instead of by hearting, you to understand the meaning of the equation. That should come as a picture in your mind, right? What is the picture here? Picture is you apply a force. Force means hit or bat or something. How much is its acceleration? How much force you give? Divide that with its mass. That is actually logical. The more the mass, less will be the acceleration. Is it not? So the force which you are giving, you just think about you philosophically you to understand. See, now we will slowly enter from science to a terrain of philosophy. So if you to really understand science in its meaning, you have to understand the philosophy of it. Okay, so that is what we miss when we try to by heart. A is equal to v minus u by t, f is equal to m. We don't do that. You understand the philosophy. So what is happening? You just see philosophically this equation. How old you can visualize? You tell. A is equal to f by m. How old you can visualize it? Creative way. I am waiting. No one who is creative here.
Sir, can you repeat the question one more time?
I am asking which are the ways in which you can visualize this equation in a very creative way. It's a ball, tennis ball. Shivananda is coming and playing with a bat. Tuck. One force she applied. We are telling it will accelerate. Security force which Shivananda applied divided by mass of the ball. How old you can visualize this? Or you are very happy by hurting it? All the artists, all the painters here, all the yoga artists, all the writers, bloggers, are you able to visualize this in any way, my dear friends?
Sir, do we have
What do
to
you mean by visualizing?
Come again, repeat.
What do you mean by visualizing? Uh,
What comes to your mind when this equation, when you remember what is there in your mind, what it comes into your picture? See, when you think about a movie which you saw, what is the last movie you saw, Avinash?
Real.
Mirror. What is there in your mind about that? There will be something, right? When you think about that movie, there will be some images which will come into your mind, right?
Yes, sir.
That is visualization. Or you think about some place which you visited after before 2 years. When you think about that, some visualization, some feeling will come to your mind, right?
The riding a bicycle.
So some riding a bicycle comes to your mind. Okay. Someone else was that. Ayati was telling something.
Sir, I was not there. I was asking you whether do we have to explain that equation or something like that?
No, I'm asking what is it coming to your mind? See, certain equations very difficult to visualize. Ax square plus bx plus c is equal to k. It's very difficult to visualize, right?
Yes, sir.
Yeah, but this is simple equation. You should be able to visualize.
So I used to compare the bicycle of my and my friend. My bicycle have more mass, but my friend is little bit thin. So if I apply more force, or it will go faster. I will think about that.
Okay, good way, very good way. See, think like this. Assume that you are applying some water. Assume this is a sponge. Okay, assume this is a. I'm just telling one way. This is some sponge ball. Assume you are applying water. What will happen? This sponge ball will take the whole water, right? Is it not? The sponge ball will take. So how do you decide how much water you have in a portion of sponge ball? What all things matter? If you put water in a sponge ball, you take a small portion of the ball sponge. How much water will be there is depending on which all things.
So the quality of that sponge.
Okay, what else?
Size.
Volume.
Size. Okay, size of the sponge, right? Yeah, volume or size. The more means you will get less water. Is it not? Small sponge means you will get more water. Is it not? 1 cup of water, if you put in a huge sponge, you will get very less water in one point. If it is a small bowl, it will get full sunk. Right? Right? Okay, what else? What else is important? Balls, okay. Boss, is water important? How much water you put? Right? See, this is how we miss important, very important things. If 2 cup water you put, sponge will have more water, right? Yeah. So just look at, think of some ways to visualize this. Okay. So think like you are applying a force, and that force is getting applied to full particle in this object. Then only it moves. So if this is huge, it will move less because that force has to reach the entire part, like sponge and water. Or it could be some other example you can think. Or if you put more water, you will have more water in a unit space. Just think like force you are applying that has to reach the entire particle in this body. Then this body moves together. The entire particles moves together. So the bigger the body, it will move less because the same force is distributed across. Right? So more force you apply, it will move more because for each particle you get more force. So you should be able to visualize equations, right? Now, second equation what Shivananda told is, actually this is very straightforward. Don't by heart this, okay? V minus u is what? Change in speed. Starting speed was 10 kilometer per hour. End speed was 50 kilometer per hour. Assume this traveled in 3 hours. 50 minus 10 by 3. So you know per hour what is the distance traveled. That is speed. So always acceleration is difference in speed divided by time. Yeah, and same equation, you remember this equation, v is equal to u plus at? Do you remember this?
First equation of motion.
Yeah, this equation actually you can get from here. You can get it two ways. You can one you can get it from here, because if A is equal to V minus U by T, this T if you bring to the other side, this will become AT is equal to V minus U, right? This T, V minus U by T, this T if I take it to the other side, this will become A into T is equal to V minus U. Now this minus U if I take to this side, this becomes AT plus U is equal to V, right? This minus U if I take this is the same equation, V is equal to U plus AT. One way. Another way is what we did in the last session. Remember this? This is what we did in the last session. Is this next way? Remember, initial speed is u. After 1 second is u plus 1 into g. After 2 seconds, u plus 2 into g. After 3 seconds, u plus 3 into g. After t seconds, u plus t into g. So g is, because this is gravitational. Otherwise, this is a, u plus t into a, or u plus a. So this is actually, you can visualize this. How do you visualize this? A ball is dropping, you assume it has some speed. So every second speed is increasing by 9.8, 9.8, 9.8, 9.8, 9.8. So after 1 second speed is u plus 9.8. For 2 seconds, u plus 2 into 9.8. 3 seconds, u plus 3 into 9.8. T seconds, u plus t into 9.8. This is the same equation which you are writing here. Speed is starting speed plus acceleration into time. Why it is? Because acceleration is a change in speed in 1 second. So in t second, t. So you have to understand the equation, then you don't have to by heart. Yeah? So in this, these are the quantities. So this is a very basic equation of motion. Don't by heart. Most of the equations you have to study, you can visualize. Spend some time with the equations. Otherwise, the equations will look monsters to you. Monsters. Night when you sleep in the dream, equation will come t square plus x, this thing, especially before the exam day. This is the most complex equation you have studied. The toughest one in school. Or all are easy for you.
So for me in maths, it was my exam, and when I was sleeping, I was sleeping, and then in between something used to happen, and then I used to think about that equation.
See,
What's
this is the thing. This is because you know that equation is becoming a monster to you, right? So you tame the monster, taming, right? Okay, so we will tame another equation. Who all have studied Newton's kinematic equations and all these all things in the school? Who all have studied?
Me.
Okay, so we will tame another equation. So those who are not able to understand, leave it. Okay, I'm just trying to get into. So those, maybe if you are able to get it, you can do it. Okay, now let us assume same ball, same case, and all those things. Let us assume we are firing a rocket. Okay, maybe starting speed maybe 0 most of the time. Now when you fire the rocket, it is standstill. Now assume it is you or something. Now you fire the rocket. You know what is the acceleration it is picked up. So somebody is asking, after 5 hours, where will the rocket be? How many kilometers it has traveled? How do we count? Fire the rocket.
Is equal to
Is equal to? How do you calculate? Don't tell me
u.
the equation.
Sir, we need to find the mass.
We need to find the mass. Okay, right? Assume like you mass is m, like in the previous case. You apply force, you know what the acceleration it has picked up. How do you know how much distance you have covered? So let me ask you this. With the rocket, let us assume after 5 hours, if we know the speed of the rocket, we know how to calculate the final speed, right? The rocket starting speed, let us assume at some point is u. And if we know its acceleration, we know the final speed because v is equal to starting speed plus a into t, acceleration into time. That is v is equal to u plus a t. We studied. So we can calculate the final speed if we want. Okay. Now you tell me, if you know the initial speed and final speed of anything, and you know what is the time taken if it is uniform, how do you calculate the distance? Distance covered?
Speed into time.
Speed, which speed you will take, u or v?
V, because using rest. At rest.
Average speed.
Yeah, that is what we spent time yesterday, right? Rishikesh brought that point. You remember? How can you take v? See, if you, that's what I was telling. Let us assume you are going in a car. The first hour the car is going at 20 km per hour. The second hour in 30 km per hour. Third hour in 40 km per hour. Fourth hour in 50 km per hour. Now somebody is asking in this full 4 hours how much distance you have covered. Will you take the final speed 50 to multiply by 4? Won't you get the wrong result, Avinash? At 50 you achieved on the last lag only, right? It's the final speed. You can't take the final speed. Your starting speed was something else. So you should take average speed if the acceleration is uniform. The acceleration is not uniform, you can't take. Let us assume for 3 hours 55 minutes you travel at 10 km per hour. Last 10 minutes you increase the speed to 50. Then you can't take average of 10 and 50. Okay, yeah, okay, so you have to take average speed, very important. Okay, so it is, as all of you have told, distance covered is average velocity into time. What is the average velocity? Yeah, do you all get this? What is average velocity? Did you see what Rishikesh is written? Do you agree? What is average velocity? Starting is u, end is v. What is the average velocity? Do you
U
agree?
plus V by 2.
Yeah, that's what Rishikesh has also written. Do you all agree? See, average of any two quantity is first one plus second one divided by 2. You have 80 marks in physics, 70 marks in chemistry, 50 marks in biology. What is the average? How do you calculate? 80, 70, 50. How do you calculate?
80, 70, 50 by 3.
Yeah, 80 plus 70 plus 50 by 3. Average is a very simple thing, right? Add all the parameters, divide by how many parameters you have. You get the average value. So here it is u plus v by 2 into time. This is the second equation, which is called as kinematic equation coming from Newton's laws. Right? What is it finding out? What is the distance covered? So if a rocket is firing, okay, maybe now you know rocket has reached so and so point, its speed is say x kilometer per hour. Now you know the speed, and it is accelerating in so much meter per second. That is its acceleration. Then you can tell, say in next 1 hour the rocket will cover so much time, right, with this equation. But you have to calculate what will be the speed at that after that 1 hour, and then. But here there's a small problem in this. Most of the times, if you are asking, okay, now the rocket is going, it's accelerating at so and so rate. After 5 hours, where will the rocket be? Then using this equation, if you have to calculate, you should first calculate what is its speed after 5 hours. final speed, then only you can calculate how much speed the rocket will cover, how much distance the rocket will cover, right? Using this equation, if somebody is asking you, now our Mars rover has just taken off, it is accelerating in so and so meter per second, its present speed, say, is so much. Its present speed is so much, 300, 400 meter per second, but it is accelerating at, say, 10 meter per second or so. Let us assume. Where will that rocket reach in 5 hours? That means how much distance it will cover. Using this equation you can calculate, but for that you have to get V. V is that what will be the speed after 5 hours, which we don't know. We have to calculate. So in order to avoid that, we can replace this V with the equation which we learned called V is equal to U plus AT. Because now you know the starting speed, you know the acceleration is A, you are telling after 5 hours. So you can calculate this V, you can change with this equation called, instead of V, you can write U plus AT. Okay. So if you don't understand this, don't bother, don't break your head. Okay. But if you are able to understand, if you have an interest, you can look at it. This is how equations get formed. You established a simple principle that distance covered is velocity into time. Now velocity you are calculating as average velocity because speed is changing. Now you put that equation, but now we are becoming ambitious because this V we don't know most of the times. So now I want to calculate the rocket which I am sending. Where will it reach after 5 hours? I know what is its speed now. I know how it is accelerating. So those are the only two information I have, U and A, current speed and acceleration. And I want to know in 5 hours, where will it reach? So with these 3 parameters now I can find out. Yes. Now here what is left now is simple mathematics. U plus U is 2U. So this will become 2U plus AT by 2. Now we will remove this bracket. When you remove this bracket, this will become 2U by 2 plus AT by 2. Whatever is there, this expression will become 2U by 2 plus AT by 2. 2U by 2 is U plus AT by 2 is half AT. Now we will remove this bracket. That means you multiply this also with T, this also with T. So U into T is UT. Half A into T is AT square. So this is a very famous equation called kinematic motion. You don't have to study this derivation, but I just showed you so that you know where is it coming from. Those who are interested can look at it. You don't have to study this derivation, but you know now how equations are formed. What is its root? Actually, it is coming from a very simple principle. But if you by heart it as is equal to UT plus half AT square, you may not know where is it coming from. Okay. So those students who haven't learned this, you leave it. But understand that you have a method. This is how we calculate. We tell now within X hours we will reach that destination. Within this many hours we will reach there. Actually, we do it using this calculation. So if you now the current speed of the rocket, which is U, and if you know how it is accelerating, we can tell after X minute or X hour where will it reach. This expression will give you how much distance it will cover. Okay. Yeah, it's a displacement. Yes, distance covered. Yes, this is the distance covered. See? Displacement or distance covered. Right? This is how much distance the rocket will cover. Okay. Right. So don't break your head, but just understand this is how equations get formed. Okay. So who all have studied this equation in school? S is equal to UT plus half AT square. Who all have studied here? Who all have studied? Shivananda has studied. Who else has studied in school? Only Shivananda? I am sure class 9, class 10 students would have studied this. I am very sure. Class 9, class 10 students, this is there for sure. Those who have completed class 9, they would have definitely studied this. At least in class 10 for sure. No? Which class you are in, Diljit? Yeah, Ananya studied. Diljit, Shreya, which class you all are in?
9.
9. No. Shreya, which class? And Gokul Krishna, which class you are? Attempt finish. You would have studied, na, Shreya, this equation? Have you or haven't? Then tell no, yeah. When I am asking, have you studied? What bothers you to just tell yes, right? Okay. If I don't know, if I don't get inputs from you, how can I cover it? Just tell na when somebody asks something. Is it a big deal for you to just message yes? Who are other people who have studied? Shreyas, Roshan and all, have you?
No, sir.
You haven't. Okay. Okay. Then just answer no, if somebody asks something, have you studied? At least yes or no, you tell na, so that it becomes easier for me. How much time I have to spend now for this? Just to get an answer from you, to call each person. You are not nursery kids, right? To call each of you specifically person by person, right? Yeah. Okay. When you take something, you have to give something back. Okay. When you come to the class and you know I am spending time with you, the least thing expected from you is to give an answer to a question, right? It is like not a science question. Where have you studied or which class you are studying? You can't tell that I don't know my name and which class I am studying, whether I have studied, right? Okay, right. Now, this is Newton's third law. One of the person who are attending this class sent me this. So I thought I will put it in this presentation. You know Newton's third law. So a person from who is attending here sent message me this. So I felt, yeah, this is a beautiful way of explaining this. I won't tell who was sent, right? So that was the, see, till now what we covered, the first thing what we covered is called Newton's first law, that inertia and all. Okay. Now the second law is that equation, F is equal to m into a and other things. Third law is every action has equal and opposite reaction. If you study, not a big deal, like whenever like you swim and all, you are able to swim and all because of that. You put water this direction, you will move in the opposite direction. So wherever you apply a force, you will have an equal and opposite force. Your car goes and hits the tree, then your car is applying a force on the tree, and tree will apply equal and opposite force on your car. If two cars come and hit, this car will apply a force on this car, equal force will be applied on that. It's called Newton's third law. Okay, but that's nothing big deal in that. Okay, now you tell me, let us assume if there is a formula race, these are the cars, who will win?
The car in the beginning,
Currently,
in the front, the car in the front.
stand,
No, sir, the car in the front.
car in the front. Okay, what? How can you tell it? What if the person behind overtakes?
Any car can.
Any car can.
Any car can.
What characteristic of the car will make it win?
Acceleration.
Acceleration. Rishikesh told acceleration. The car which accelerates more will win. Okay, there are many other parameters. Now you don't tell me it depends on the driver and it depends on the turn, whether it will follow. All those things all of us understand. So we are studying science here. So I agree with Rishikesh, those who can accelerate more. What property of the car will make it accelerate more?
The streamlined shape, because then
Yeah, shape and Ananya, shape and
shape and the friction by the air and land.
yeah, but friction is same for all cars, na? Friction is same for all cars. Now shape, you have a brilliant point there. The aerodynamic shape is important, but almost all the cars are very similar shape right here. Is it not? It looks very similar shape.
Yes, sir.
So what property of the car, if you are building the car, what will you do to ensure that your car wins?
Mass.
Engine. Powerful
Yeah,
engine.
mass and engine. Yeah, so two important points you are told. One, you will try to reduce the mass, but you have some limit. Now Shivananda tells engine. What? Powerful engine, right? Shivananda told powerful engine. Powerful engine. What does it mean? What do you mean by powerful engine?
So the engine which gives more acceleration to the car.
That is right. But what is meant by power? What is meant by power? Powerful means what?
Doing more work.
Doing more
More
work.
work.
The engine that can process more fuel to make more energy.
Engine can process more fuel. Okay.
The engine which uses lesser amount of fuel to give more power.
The engine which uses lesser fuel to do more work. Okay.
The engine which is more durable.
Engine which is more durable. Okay. So I I asked this question. What is power? When you tell this car has more power, this engine has more power, or we tell that Joe Biden is powerful person in the world, or we tell Mike Tyson is very powerful. What does the word power means?
Work done by something or someone
Work
in a
done by
particular time.
who told this? Ananya told. Okay, so that is a beautiful thing. Okay, so she told more power means you can do more work. Let us assume you have an engine of a car. Okay, you have another car, same weight, same mass, same shape. If it is double the power means it can do double the work, right? Right?
Yes, sir.
So for example, if you have which one are the like engines or motors which you use at your house?
Generator.
Generator. Okay. Do you
The
use
fan, the rotating motor.
rotating motor? Do you use pump to pump water in your house? Yeah. So let us assume you have a water tank. You pump water. Let us assume it takes 1 hour to fill the tank. Okay. If you want to fill the tank in half an hour, what you will do? What can you do?
Increase the power of the generator.
Yeah,
The
you
pump.
pump. Yeah, you change the pump. You make its power double, so that the water thrown by you is double, right? So whatever the other pump throws in 1 hour, this will do in half an hour, right? In other means, in 1 second, if you take the water thrown by this second pump is 2 times. Okay, so that is what we tell like whatever Ananya told, it can do more work. Here the work is pumping water. Here in this case the work is driving and taking the car. Yeah. So now it comes to the point, what is work? When you tell that you did so much of work, oh my father is giving me so much of work, or the class teacher gave me so much homework yesterday, what do you mean?
Sir, can you repeat your question?
Arey yaar. Anybody heard this? Can anybody repeat? Did anyone hear?
What is work?
What is
What
work?
is mean by work?
Yeah, Ritesh, we are asking what is meant by work. If somebody tell I did so much of work today and I got tired.
Sir, exhaustion of energy.
Hey, you're right.
And the person which we use energy for some particular purposes.
Purposes, okay. How do you quantify your work?
So when some uh, force is acting on something to to bring about some change.
Okay, you tell an example of a work. Let us assume
Sir, can
that,
I?
yeah, Ayati, yes.
Amount of energy used.
Amount of energy used. Okay, fine. But what do you do with this energy? When you tell you are doing work done, what do you do actually? See, now we will get to philosophy, okay? Be careful. Now slowly from science we'll get to philosophy. Okay. So now let us assume we give a punishment to say Alan. Okay. Tell Alan, you run 2 rounds in the ground. You didn't do homework yesterday. Run 2 rounds in the ground. Right? What will happen to Alan? He will run 2 rounds. He will be very sad till the point he will see that Elisa is running 3 rounds and he feels like happiness. Right? He did work. Alan did work. 2 rounds he ran. He was very dejected. But then he saw Elisa has to run 3 rounds. So he feels slightly. A slight smile will come in Alan's face. Okay, at least Elisa. When will Elisa feel happy? Elisa will feel happy when she sees Mega had to run 4 rounds. Yes, right? Yeah. So what happens? There is some relativity going on there. But if we keep that emotional part aside, actually speaking, the work done by Alan is he ran 2 rounds, but Elisa had to run 3 rounds. That means Elisa has to cover more distance, right? Elisa has to cover more distance. So obviously Alan is happy because I ran this much distance, but she has to run three rounds, so she has to go more distance. Why Elisa is happy? She feels I am running 3 rounds, but Mega has to go one more round. So she has to do more work. Right? Now let me ask this question to Mega. Given this is the scenario, Elisa is running only 3 rounds, you are running 4 rounds, and Alan is running only 2 rounds. How can you make them do more work than you do so that you feel bit of satisfaction?
Make them run more rounds.
No, round is fixed. Mega, think hard. You have to run 4 rounds. Elisa has to run 3 rounds. Our friend Alan has to run only 2 rounds. Now they are laughing at you, they feel so very happy. Now how can you make them do more work?
Sir, give them some other punishment.
Give some pension.
Megha needs to give them some other punishment for laughing.
Yeah, same punishment. So that is okay, fine. Now don't tell me you can put your hand so the other person falls down. Make
Run
them
faster.
make her tell me.
Run faster to make them feel that they are
Run
more distant.
faster is okay, but actually speaking, even if you run faster, the work done doesn't change because it's the same distance, same person.
Or they can like go half round, then make them go back to the starting and then go again. So
Won't make much difference, Ananya. One ground you go half and come back also it's same. See, unless you increase the distance, it doesn't make difference. Distance is same. We are telling 2 rounds.
So we need to take them to some other ground.
No. This is that all things are same ground. 2 and 3 and this thing is fixed. You tell me what else. Is the method.
So make them wait for you to finish.
Nelson is telling make them round around the corner, so there is more distance. The distance is fixed. That's what I'm telling. You can play with distance.
Make them run faster.
It doesn't make a difference. Actually, same distance you will cover early.
Sir, we can give them
The
load
Megha
on their back so that.
Yeah. What? Ayati, yes. Ayati, what did you say?
Sir, I've seen in movies that they take that tire and then they run.
Yeah. See, that is brilliance. So Ayati is telling, put a tire on the head of Elisa. Okay. How many tires Ayati for Alan then?
Sir, 2.
2. When Ayati becomes teacher, I think kids are gone. See, is it not? Is it not a brilliant method? See, same 2 rounds. Why with the tire they have to make more work? Why? Why if you add a tire, it becomes more work?
It's heavier and
They need to carry it.
Okay, so what?
Sir,
Yeah.
we need to carry that tire which is heavy.
Yeah, what if you give a necklace to them they get to carry? Does it add their work?
more inertia.
Yeah, you see what Rishikesh is saying. You are adding more mass. That's what you just learned. For more mass, you have to have more force. That's what we learned, right? If you have something with more mass, if you have to accelerate, you have to give more force. That is why force is equal to mass into acceleration. More mass means you have to give more force. If in Elisa, if you give a garland to her or a small necklace or some kind of an earring, it's a very light mass, doesn't increase much of force. But see, that is why Ayati is brilliant. She took tire itself. So you put a tire on their head, they have to spend so much of force. Is it not? Now you tell me, you assume you are cycling. Okay, if you have to cycle 1 kilometer, 2 of you. Okay, 2 of you are cycling 1 kilometer. You are doing same work. You are doing same work of cycling 1 kilometer. But if one person has a luggage on the back or a double on the back, that person has to do more work because that person has more mass. Right? So 2 things we understood here. When we define work, there are 2 things we understood. First, we understood Megha is doing more work because she has to go more distance. Elisa is doing more work compared to Alan because she has to go more distance. So we understand that in cycling, if you cycle 10 kilometer, you have to do more work than the person who is cycling 1 kilometer. So if you have to do an activity for more distance, you are doing more work. Okay, that's what we learned. And second thing we learned, if you are to apply more force, Most probably because the mass is more. If you have to apply more force, then also you are doing more work. How I will make it clear to you? Let me ask this. Let us assume Mega and Elisa are walking 1 kilometer, but I am making Elisa walking that 1 kilometer in a steep mountain terrain. Who will do more work?
Lisa.
If Mega is walking in a plain terrain, if Elisa is made to walk in a mountainous terrain, both 1 kilometer, who will do more work?
Sir, Elisa will do more.
Why?
Sir,
Why?
because she has to work against the gravitational force also
Yeah,
at the same time.
exactly. She has to apply more force because she has to work against gravity. Right? She has to fight with Earth. Mega doesn't have to. Mega just walks. You understand? So if you have to apply more force, you have to do more work. So that is the classic definition of work. When you tell somebody is doing a work, that means you are applying some force, more the work. More the distance, more the work. So work is equal to force into distance you have covered, or you normally tell displacement because it is vector. But you have to visualize, don't by heart. Work is equal to force into displacement. Don't by heart. Understand the concept. Why work is equal to force into displacement? This is because of this. More force you have to apply, you have to do more work. That is why Elisa, if she goes in a mountainous terrain 1 kilometer, she will get sweat. Mega may sing a song, her English songs and Korean band, whatever she is putting profile and she walk. 1 kilometer after that, Elisa will sweat because she has to do work, more work compared to Mega. Yeah. So work is defined as force into displacement. Now, when it comes to a car, an engine, when you tell engine is doing work, it has to apply force to move the car. Well, it is depending on the mass, and it also depending on how much force you have to apply in a car is depending on one, its mass. Second is what?
Acceleration.
It's acceleration, because force is mass into acceleration. So how much acceleration? You want to get more acceleration, you have to give more force. Okay, so the mass and acceleration, depending on that, the engine has to give a force and how much distance the car goes. These two things, the displacement into the force, is what is called work. Now let us come back to Ananya. Ananya, you tell me, what was your definition of power?
A force acting on an object to
Yeah, but you told something for power. So,
the work done by something or someone to create a change.
now let us tell this. Let us go with this example of water pump. One water pump is pumping water and it takes 1 hour to fill the tank. Another water pump is pumping and it is filling the tank in 30 minutes. The second pump is more powerful, right? That is why it is filling the tank in 30 minutes. What is the difference in work done? Both are doing same work. It is applying a force and it is taking the water to the pump, to the tank, same distance. What is the difference? You see, that is what that Rishikesh is written there. In 1 second, how much work one person can do, that is the difference. Is it not? In 1 second, how much work one can do, that is the difference. Let us assume we put Haripriya and say Ritish in a cycling competition. Okay? Cycling competition. Same cycle, same mass, same distance. Let us assume Ritish, by the time he covers, say 100 meters, let us assume Haripriya so smartly she covers 200 meters. What will help her to do that? She is doing more work than Ritish in 1 second. Force applied by Haripriya is more. Because of that, she will cover more distance. So if you compare two cars, you tell this is BMW engine and this is say Maruti Alto. Why you tell BMW is more powerful? Because in 1 second, BMW engine can do more work, which means it can pull more mass, it can apply more force, it can go more distance. Right? So when, let us assume Avinash is going for this arm wrestling with Arnold Schwarzenegger, what will happen? Arnold Schwarzenegger will fear and run away, right? By seeing Avinash, what will happen?
Never.
What will happen if Avinash and Arnold go for a hand wrestling?
Most probably his 5 fingers will break.
But why Arnold wins?
Because of his power.
He can do more work in 1 second. See, Avinash also can do work. See, if Arnold just keeps his hand like this, Avinash, hit, you also get some satisfaction. Then Avinash can hit. So he can do that work. But if you tell in 1 second who can do more work, that is Arnold. Is it not? So that is why we tell he is a powerful person. Right? It is not just doing more work, it is doing in 1 second who can do more work. So that is what we call as power. Do you understand this? So now you have to now see the terms. We are telling, when you tell somebody is doing a work, that means it is depending on two things: how much force and what is the distance covered. This force into distance is the work done. Now, when we tell somebody can do more work in a given time, we call them powerful people. When we tell Joe Biden is powerful person, means he can do work more easily than you. Right? Is it not? Is Uddhav Thackeray more powerful or Ayati more powerful? As on today, it is Uddhav Thackeray. Why? Uddhav Thackeray is the CM of Maharashtra. Maybe tomorrow Ayati will become more powerful. We don't know. But today, Uddhav Thackeray can do a work faster than Ayati. Okay, except baking and cooking. Right? But a bigger thing, that's why we call them in English, they are powerful people. Because it's coming from science actually. Right? Okay, so you have to understand this definition. Now let me ask you the golden question. This engine does some work, car moves, or you cycle, you do some work. For doing some work, you need energy, right? In the car, you put fuel. For you, you put another fuel through your mouth. What happens to this energy when you do work? The car goes, it is burning the fuel, or you do some work, you are using the food which you have taken. What happens to this energy?
So the energy will burn.
Burn. Okay. See, I will take 10 more minutes today. Okay? I have to finish this topic today, and then next week I want to start with the relativity of Einstein. Okay, that's right. So you please bear with me for 10-15 minutes. Yeah. Those who have an urgency of this thing, you can leave, you can see the video. Okay, otherwise I want to complete this. Yes. Tell me what happens to this fuel which car is burning, or the food which you have eaten when you ride the cycle, or the electricity the pump has consumed to pump the water. What happens to it?
Converts to mechanical energy.
What mechanical energy it is converted here? Let us assume the car has gone someplace and stops.
Sir, can you repeat the question?
No, I'm asking this, whatever fuel you have used, what happens to that fuel? You use that energy, right? In cycling, you use the food you have taken, that energy. In The pump you use electricity. You use heat energy to mechanical. Then what happened to that mechanical energy? After the car
It is
stopping.
getting converted into the heat energy, the mechanical energy.
So the car, whatever car has run, that entire mechanical energy becomes heat. When you cycle,
Yes, sir.
yeah, when you cycle also, it will become heat.
Sir, maybe some of it is used for like for against the frictional force. So some is getting
Beautiful. Okay. So
transferred
say
to the ground.
excellent. So the point is now you focus. Okay. Now you focus. This is where we have to philosophically understand science. See, the universe is formed maybe at some point, or it was there for a long time. But then the content inside the universe doesn't change. All other magic people tell on this thing, on cream, I give this magic from air, apple, and all those things are bullshit. You can only change one kind of stuff to another kind. So once the universe is formed, or it was there for a long time, that is debatable. Whatever is there inside this universe is there. Jo hai, wo hai. It can change shape. It doesn't go anywhere. Stone can become sand. Or like Ananya told, you put some fuel in the car and the engine can use it to run, so that car will go. But then that energy, what happens? That energy doesn't get burned. That energy, some energy will become heat energy. Some energy, because when the car goes, in the atmosphere, it will produce some heat. It will produce some wave, right? If you stand near a car, when car is going, you will feel that air effect. So that also you need some energy for that. And for friction, like she told, you need some energy. Whatever energy you have taken, it will be there in this universe. It cannot go anywhere. Cannot go anywhere. So you have to understand universe as a closed box. Inside that, there are certain things. Shape of those things will change. It is like you can tell that paratha dough. You can cut it, make small paratha, and with that you can make it round, and you can make paratha and eat it. But the total stuff, whatever you had, it is still there. It doesn't go anywhere. It is there in one shape or another shape. Okay, then in this universe you have only two things. Whole universe, you have only two things. You know which are they? Yeah, what? Including life, if life is all consisted of only two things. Whole universe.
Force and matter.
Repeat.
Force and matter.
Yeah, the whole universe has only two things: matter and force. Force, you can take it as energy, like to apply for field energy. Matter and energy. Matter means Megha, Shivananda, Alan, Ananya, Nelson, all of our bodies, the computer, the cloud, the soil, solar matter. Energy is what helps you to apply a force. For me to move my hand, for car to move, for a wave to move like this. For that, you need energy. These are the only two things which is there in this universe. Whatever energy it was there in the starting is there now also. Whatever matter was there in the starting or endlessly, it is there now also. Right? So it may contradict at some point, you might have some contradiction with this at some point, based on some other philosophies, but you have to understand this is the standing principle of science. We call it as, there's a law for that. We call it as law of conservation of energy and law of conservation of mass. That means whatever is the energy in this universe, it is conserved. Whatever is the mass is conserved. So you go in a cycle from here, you are riding the cycle, you are using the energy from the food you have taken. That energy, with that energy you do this work. But does that work go waste? No. When you reach the top, work becomes energy. So work and energy are one at the same. You use energy to do work. Whatever work you have done becomes energy. Rishikesh, message to everyone, not personally. Message to everyone so that I can answer others. Okay. So whatever work you have done becomes energy. Whatever energy you have, you use to do work. Right? So energy and work are one and the same. So now if you have food you are taken, using that you cycle, and that you do some work, and that becomes energy. That is, we call this as one energy, potential energy. Now using that you again do some more work, and that becomes another energy. But it doesn't go anywhere. Okay, so forget about this equation part of it. Now you see, same thing here. You have a pendulum, it is in this position, it moves from here. Does the pendulum has a memory to know that to go to the same position? You see the same height? It doesn't have life to have memory. This was something which Galileo had done an experiment. You know, if you put a ball like this, it goes to the same height. Doesn't have a memory. But it goes to same height because the energy is same. Energy becomes kinetic energy, or it becomes potential, all those different names. But the conservation of energy means it just cannot go. Probably if you have friction or something, it will go to a lesser height. But if there is no friction, air resistance, something, it will just continue to go like this. In your clock, it happens like this, is it not? It continuously goes like this, if there are no other things at play. So this is called law of conservation of mass, law of conservation of energy. Do you get this? Yeah. Now I will tell Rishikesh, you get energy from the food, right? You get energy from the food, and from the food, depending on what food you take. That's what I'm coming here. You see, this is a cycle. Sun produces light energy. So that's why we told in the universe you have only matter and energy. So when you tell sun is producing energy, there is a particle which is responsible for that energy. You know what? When you tell sun is producing energy, one particle comes from sun.
Photon.
Yeah, so that is what is called photon. Okay, so that photon is a particle. So that is giving that energy, and using that energy, plants convert that into some another format using what we call as photosynthesis. Sometimes if you eat that fruit or rice or something, you get energy from that, originating from that photon of the sun. Using that energy, you may do some work. When you do that work, it may become heat energy or something. And it is there in this universe. Sometimes if that plant fall under soil, it will become what we call as petroleum, fossil fuel, and all those things. Using that, we can make something else. Right? So this is what we call energy only changes from one form to another. Right? So that using the energy, you do work. Whatever work you have done becomes energy. Okay, so I'm just I'm putting in the slide. This is a summary. So the summary is what is work? You first learned work is force into displacement. You see the two things which we told when what is called work. You do more force, that we put the tire on Elisa's head, she has to do more force to move. So she has to do more work. Or Mega, we made her to run 3 rounds, she has to do more work. More force, more displacement. So what will be its unit? Newton and meter. That is what we call as joule. So Newton is the unit of force. Displacement's unit is meter. So the unit is called Newton meter. That is what we call as joule. Same is the unit for energy, because work and energy are the same things. Energy becomes work, work becomes energy. Right? Now power, we told what is the work done in 1 second. That is power. You tell me what is the unit of power?
Joule.
That is work. Work by time. That is joule per second.
Joule per second.
We call it as watt. Forget about these things. We call it as watt. You see your house, you tell light bulb, you tell that is 40 watt, this is 50 watt. You know what does it mean? That is its capacity to do work, how much work it can do in 1 second. How do you tell the power of engine, car engine? How do you tell the power of bike or car engine?
Horsepower.
That is horsepower. It is another unit of watt. One
By
horsepower is,
how much work it can do?
yeah, horsepower means that is some watt, some 700 plus watts. That means how much work it can do in 1 second. Yeah. So when all the powers we tell in watt. Okay. Right. Now energy is same as work. If you have energy, using that energy only you can do work. Whatever work you do becomes energy. So you eat food, from that energy you do work. Whatever work you have done becomes energy, and it is there in the atmosphere, in the universe. Right? Okay. So there are two very kind of energies. Two energies most commonly people use: potential, kinetic, and which all things you will learn later. So this is what we have covered so much, is what we call as Newtonian physics. You see where it started. If you summarize, started from Galileo. We studied that he did experiments. From the experiments, he came up with the concept of inertia. Okay, and then we had Kepler's laws. So that Kepler's laws gave some picture of the universe, especially the solar system. And then Galileo gave some idea about inertia. From that we got the concept of force. What does force do? It is changing the speed. And then Newton defined it with equations, that force is mass into acceleration. And once you got hold of force, from there you define what is work. Work is force into displacement. Once we caught hold of work, we caught hold of energy by telling you are using energy to do the work. That means work is becoming energy. From there, we came into this idea of the universe, that the whole energy of the universe is being conserved. The whole matter of the universe is being conserved, so that we have a definite idea about how universe is functioning. So we do not have a very clear idea about the origin of the universe, how exactly it happened, was it eternal? But now we know whatever is there is there. You can't change it. You can change the shape and form, not the content. Yeah. So I will stop it at that point, and I will take questions.